Can you see everybody?
Our experiment is the impact of temperature on amylase activity. Our group's prediction is that as temperature increases, this will speed up the activity. The independent variable, which is the one that will be manipulated, is temperature. The dependent variable, which is the one that will be measured or observed in response to the conditions, is amylase activity. The positive control is room temperature. The negative control is not putting amylase into the solution. The controlled variable is each solution was placed in a set temperature warmer.
For our experiment, we placed 1 milliliter of starch and 0.25 milliliters of amylase in 6 separate test tubes. We placed a set of test tubes, 1 amylase and 1 starch, in warming tubs at temperatures of 20 degrees Celsius, 40 degrees Celsius, 60 degrees Celsius, and 80 degrees Celsius. We also placed a set of test tubes of amylase and starch and ice water, which was 2 degrees Celsius, and a set at room temperature, which was 21 degrees Celsius. We left them approximately 15 minutes to heat up or cool down within their environment. After this time had elapsed, we had 100 microliters of iodine ready in each well of a watch plate. The amylase was combined with starch, and we used a micropipetter to draw up 500 microliters of the solution and place it in the watch plate. We continued to do this in 30-second increments. The results were recorded until color change no longer occurred in the wells. The experiment was then repeated for each separate temperature.
Now I'll explain the graph. As temperatures are lower and higher than room temperature, the amylase activity decreases, taking starch longer to be converted to maltose. In regular room temperature, amylase activity is very quick.
Our conclusion is that our hypothesis was incorrect. The activity of amylase was not increased by higher temperatures. The amylase activity was greatest at 40 degrees Celsius and 21 degrees Celsius. We did not replicate our experiment because our hypothesis was incorrect.